In this video, we're going to start Chapter 9.
And Chapter 9 is on alcohols, ethers, and then related compounds. So we'll also talk about epoxides. And then just briefly, I want to mention thiols and sulfides. So Chapter 9, alcohols, ethers. And then it says related compounds. I'm going to add epoxides. We are going to do some reactions of epoxides. And then two others that I'll mention here just in the beginning. So what these ones have in common are sigma bonds to an oxygen. So just remember our alcohol functional group, right? I have some sort of carbon-based group, and then it's bonded to an OH group, right? And there's lone pairs on that oxygen. In ether, carbon group, oxygen, and then another carbon group. These are all, if we look at water, you can kind of think of the structure based on water, right? Water's bent, right? Less than 109.5 degree bond angles. I have two lone pairs, right? It's sp3 hybridized. And if you were to just replace one of those hydrogens with a carbon-based group, we then have our alcohol. And if you were to replace another hydrogen with another carbon-based group, we have an ether. So in both cases, I have oxygen. The geometry around that oxygen is bent. Oxygen's sp3 hybridized with two lone pairs on them. So very similar in structure to water. If you can remember the structure of water, which most of you probably have nailed down by now. You also know the general kind of geometry of alcohols and ethers. Epoxides are a little different. Epoxides do have an oxygen with two lone pairs, but what's special about epoxides is they're actually three-membered rings where one of those members is an oxygen. So it's an oxygen going to a carbon. Let's just draw a skeletal. Going to a carbon. And then those are attached. So two carbons and an oxygen in a ring. It's still sp3 hybridized, but my bond angle is really compressed, right? This has a lot of angle strain. Much angle strain. Remember, angle strain is where we take an angle and we either compress it or expand it beyond its ideal. So if I have a three-sided ring, the bond angles are roughly 60 degrees, right? It wants to be 109.5. So a lot of angle strain. Epoxides are actually really reactive. One of the common questions that I usually get if we were in class is, does it have to be that number of carbons? Yes. You can have cyclic ethers, but it's not an epoxide. An epoxide is specifically two carbons and an oxygen in a ring. If I was to draw something like this, well, it's a cyclic ether, it's not an epoxide. So epoxide literally needs to be three things in a ring, two carbons and an oxygen. You can have oxygens in rings, but they're not epoxides if it's not two carbons and one oxygen. You can have substituents on it. I can go and do all sorts of crazy things here. Put a cyclic group, it doesn't matter, but the basic structure of it is this with the oxygen. So three-membered ring, two carbons, one oxygen. You can have substituents on it, but to be an epoxide, you need that part of it. The other two functional groups that I do want to mention, and these aren't ones that we covered at the beginning of the semester, so these are new functional groups, and that says thiol. We're not going to do much with these next two, other than I want you to know that they exist. I could draw a structure on an exam, or I could ask you to draw one, and just be able to recognize it as a thiol. So a thiol is similar to an alcohol, except that instead of an oxygen, it has a sulfur molecule. So I have a carbon bonded to an SH. Sulfur is in the same group as oxygen in the periodic table, right? It's right below it, so it's the same number of valence electrons. It wants to form the same type of bonds. So the structure of this is going to be very similar, right? It's still going to be bent. I do have 2 lone pairs on sulfur, so still sp3 hybridized. All we're really doing is swapping the oxygen for the sulfur. And then a sulfide, this is the sulfur equivalent of an ether. So an R group, a sulfur, and then another R group. So if I was to go up to my thiol picture here and just get rid of that one and put an R group there, that would be my sulfide. So similar to an ether, but replacing the oxygen with a sulfur. So just really be able to recognize those. So we are going to go through naming. So using our IUPAC rules, for the most part, actually when we get to ethers, we're going to use an IUPAC and a non-IUPAC version, a common way. The common way is actually okay. IUPAC says we can use it still. So alcohols first. So our ending is actually OL. For us, because the only other functional group we've really learned how to name are alkanes, cycloalkanes, and then alkyl halides, which are just named as substituted alkanes. We're not going to have any double bonds or anything like that yet. After chapter 11, chapter 11 is on alkenes, chapter 10 is on alkynes. I said that backwards. Chapter 11 is on alkynes, chapter 10 is on alkenes. Sorry, get it straight. By the time we're done with those 2 chapters, we're actually going to mix those functional groups, and our ending might be a little bit different. So for now, though, because I only have alkanes, so all singly bonded oxygens, and then I'll add an alcohol group to it, we can really think of our ending as ANOL. If you had an alkene, you would actually do ENOL. Because they're all single bonds, we can do NOL. If it's easier to do it that way, by all means. I like to think of it that way. Kind of how we would do it is we would replace the E in the alkane name with OL. Be really careful that your O's look like O's also. So if you write instead of print, and I do a mixture of both, be really careful. So if I have 2 carbons in an OH group, right? F is my 2 carbons, and then they're all singly bonded, so AN and then OL. So if it was just 2 carbons without the hydroxyl group, it would be ethane. Get rid of the E and put an OL at the end. I really just like to think about it in terms of the prefix for 2 is eth, and then I'm doing ANOL for my ending, so ethanol. As I started saying though, make sure your O's look like O's. If you were to write this, that's a pretty bad writing, but it needs to really, really look like an O, because ethanal is a 2 carbon aldehyde. So if you were very unclear, right, you did something like that, and I don't know if it's an O or an A, right? If I question it, I'm going to mark it wrong. A lot of times if you just have one letter wrong in your spelling, I wouldn't really take a ton off. But because it actually makes it a different functional group, it's going to be marked wrong. So ethanol and ethanal are actually 2 different things. They're both correct names, but for different structures. So just be really careful when you're writing these out that your O looks like an O. Otherwise, you're naming an aldehyde functional group. We generally do need to include the carbon number where the hydroxyl group is attached to. Because this one just has 2 carbons, it's always going to be attached on carbon 1. So essentially our rule is we want to number the parent starting closest to the OH group. So wherever I put the OH group on my 2 carbons, it's always going to be carbon 1. So I didn't actually have to say 1 ethanol in this case. With the exception of ethanol and methanol, because you only have one option, right? There's only 1 carbon in methanol. We do have to put that carbon number there. So we do need to number our parent. So we're going to number the parent. Starting at the end, closest to the carbon that is bonded to the hydroxyl group. essentially we want the lowest number for the carbon that is bonded to the hydroxyl group. So because the functional group is an alcohol, that's going to trump branches. So if I had an alcohol group here and I had a bromine here, my bromine, remember, we name alkyl halides as just a substituent. So if I went from this direction, right, I would have my branch on carbon 2. If I go from this direction, my branch is on carbon 4, but this is the correct way because we want to number it closest, not closed, closest. Right? Closest to the carbon that is bonded to the hydroxyl group. That's the functional group. It's going to trump any substituent. So this would be the correct numbering for this one. If it's in the middle, so if the same numbers for the carbon that's bonded to the hydroxyl group, I'm just going to write it that way. So for the carbon that's bonded to the hydroxyl group from either end, so essentially it's in the middle, then lowest sum for branch points. So the rule that we would have had for numbering for our alkanes, we're just putting one rule in front of that, right? For our alkanes, we always wanted the lowest sum of branch points. Here we have one rule in front of it. So closest to the hydroxyl group carbon first, then the lowest sum of branch points. If that's equal from either end, then alphabetically. So if symmetrical for branch points, the branch points don't have to be the same, they just have to be the same numbers, right? Hopefully you guys remember from before, so when I say branch points, I'm talking about the carbon numbers. So if symmetrical for branch points, then number alphabetically. Right, we want the one that has the name, right, the substituent name that's higher up in the alphabet to have the lower number. So if I put my OH group here, and then I have a bromine here, if I was to number this one from the left, 1, 2, 3, right, my OH group is on carbon 3. If I was to number it from this direction, 1, 2, 3, my OH group is on number 3. So that's this one here. I have the same number for the carbon that's bonded to the hydroxyl group from either end. Then I want to number it so I have the lowest sum. So the way that I'm doing it this way is going to be the correct way, because then my bromine is on carbon 2. If I would use these pink numbers, 1, 2, 3, it's still 3 for hydroxyl, but bromine is on carbon 4. I want the lowest sum for those branch points. So the green numbers there are the correct ones, not the pink ones. So we'll try to get rid of those here. Another example. Again, my hydroxyl group is going to be in the middle, so it's going to be on carbon 3 if I number from either direction. If I put a methyl group there and then a bromo group here, no matter which side I number from, right, 1, 2, 3, 4, 5, right, my substituents are carbon 2 and 4. If I was to number from the other direction, 1, 2, 3, 4, 5, my substituents are on 2 and 4. So this is what I mean by this one. If symmetrical for the branch points, they're on 2 and 4 from either direction, then I want to number alphabetically. So I want the substituent that comes first in the alphabet to have the lower number. So B for bromo comes before M for methyl, so it gets the lower number. So this would be the correct numbering for this one. We then have to put the name together. we do need to say what carbon the hydroxyl group is on. So we're going to put the substituents in the front, just like we normally do. And then right before the parent, we're actually going to put the carbon number. There's two different ways we can do this. So there's a new naming system. IUPAC came up with some new rules a few years ago. So if you have the 5th edition for the text, it's actually using the new rules. If you have the 3rd or the 4th edition, it's actually using the older rules. So I'll take either one. So do be careful because you can use the 3rd, 4th, or 5th edition. I do have to be able to accept both sets of rules. So kind of the deal is you're going to do carbon number, a dash. Remember, we always put dashes between numbers and letters, and then the name of the substituent. And then you're going to have the parent. And then you're going to do a carbon number. And then you're going to do the ending. So our ending for this one is actually just going to be the OL. I'll do an example here in a minute. So this is going to be the newer way. If you have the 5th edition, this is how you're going to see it. The other way, substituent. So carbon number where the substituent is, the name of the substituent. And then you're going to put the number where the OH group is, then the parent with its ending. So I'm just going to put parent ending because you're going to stick those together. So this you repeat, right, for every substituent that you have. So if there's more than one, carbon number dash substituent, carbon number dash substituent, and so on. And you list them alphabetically. Same for this one, that part doesn't change. That's a B. And then this is the carbon number that the OH group is bonded to. And that's the same for this one. The only difference, it's in a different spot. So if we go up and write some names for these ones, for this first one here, on the 4th carbon I have a bromine, so 4-bromo. Then on the 2nd carbon is my hydroxyl group, so using the older method, I'm going to do 2, and then there's 5 carbons, so pent, and then ANOL. So 4-bromo, 2-pentanol. If I was to use the newer method, 4-bromo, pent, oops. I'm still learning the new method, honestly. I've done it for about 18 years using the older way. Old dogs, new tricks, penton, 2-all. Sorry, guys. The new method, if you say it out loud, it doesn't kind of roll up the tongue as well as the old method. But once we start mixing functional groups, if we have an alcohol and an alkene and maybe even an alkyne on the same molecule, the newer method is actually easier. It sounds kind of weird, but it's actually a little bit easier. Up at the beginning when I started and I did the endings, because I'm used to only using the older method, this one kind of makes sense. If you're using the newer method, you really have to think about doing it this way. It's just that you need that AN with the parent again. So maybe replace the E in the alkane name with the OL. Just know that you might have to shove a number in between those saying where that hydroxyl group is. We'll do a few more examples, so hopefully it'll make more sense. So I don't think I wrote here the older method. So if you're using the 3rd or the 4th edition, that's the version you're going to see it. So when you're naming them, if you're doing homework problems and looking up answers in the text, that's how we're going to see it. So these couple that we already started, we might as well finish them. So this one, 2-bromo, and then older method, 3-pentanol, And then the new method, 2-bromo, pent, and 3-all. So again, we're really just moving that 3 to a different spot. So we're taking it and we're moving it right there. Everything else is going to be the same. This one I'm going to write the names above just so I don't run out of room because I have 2 substituents now. Remember, we're going to list them alphabetically, so B for bromo comes first. So 2-bromo, 4-methyl, and then the older method, 3-pent and all, and then the newer method, 2-bromo, 4-methyl, pent, and 3-all. And again, it sounds a little weird, but trust me, when we get to more than one functional group, it makes sense then. So let's do a cyclic example because we can have cyclic alcohols. So this is similar to when we did cycloalkanes with one substituent. If we only have one hydroxyl group on there, we don't actually need to say where it is because our rule says always start numbering closest to that hydroxyl group, right? Closest to the carbon that has the hydroxyl group bonded to it. Which means if it's cyclic, that carbon is always going to be carbon 1. It doesn't matter where else I put my substituents. If there's only one hydroxyl group on your ring, then you don't need to say what carbon number it's on. So I'm not going to have to say 1 cyclohexanol. I can just say cyclohexanol. That's only if there's one hydroxyl group. As soon as there's more than one, I have to say where they are. And that's how it was with substituents, right? If I had one substituent, I didn't have to say where it was because it was always on carbon 1. So if I had a methyl group on cyclohexane, we could just say methyl cyclohexane. As soon as we added a second substituent, though, we needed to say where they were. So if cyclic, and only one hydroxyl group, we don't need to state the carbon number that it is bonded to. Right? It's always on C1. If we have more than one of them will always be on C1. One of them will never not be on C1 because the first thing we have to do, right, is number them so I have the lowest numbers for my hydroxyl groups. But if there's one, we don't have to say. If there's more than one, we do. Let's put some substituents on this group. We haven't looked at these guys in a little while. And this one. Oftentimes the cyclic ones, the hardest part is just figuring out how to number them. So I know this is going to be carbon 1. And then my next rule is I want the lowest numbers for my substituents. So I'm going to go counterclockwise. If I do that, I have a substituent on 2 and 4. If I went clockwise, I would have a substituent on carbon 3 and 5. So I want the lowest numbers. So I'm going to go this way. Oop, I actually said that wrong, didn't I? 2 and 5. If I went the other way, it would be 3 and 6, not 3 and 5. Lowest numbers, though. So the name of this one, I guess we'll write it down here so we have enough room to get kind of big. So the group on carbon 2, do you guys remember what that one's called? I can actually write it up here. So I have 4 carbons, 1, 2, 3, 4. But it's bonded to the second of the 4 carbons, right? So this was sec-butyl. And remember, it actually stood for secondary, right? This carbon is secondary. It's bonded to 2 other carbon groups. So sec-butyl. We put a dash between the sec and the butyl, and then this one is alphabetized based on the B. And then the group on carbon 5, I have 3 carbons, but it's an isomer of propyl, so isopropyl. And then this one is numbered based on the I. So B comes before I in the alphabet, so my sec-butyl group is going to come first. So 2-sec-butyl, 5-isopropyl, and then the nice thing, I don't have to do it twice because I don't have to say the carbon number. So both methods, cyclohex, because there's 6 carbons, they're all singly bonded, so AN, and then my OL. So 2-sec-butyl, 5-isopropyl, cyclohexanol. If you were to put the 1 in there, which you can do, it's not technically wrong, it's just weird. If you were to do the old method, it would go between the propyl and the cyclo. The cyclo is part of the parent. And if you were to do, that's the older method, if you were to do the newer method, between the an and the all. If we have more than one hydroxyl group, then we're going to put di, tri, whatever it happens to be in front of the all. So they're going to be diols or triols. So if more than one, hydroxyl group, use diol, triol, tetraol, etc. I won't give you more than 3, so those are the ones that we'll see. The part that makes this a little bit confusing, there's a lot of little rules, and when we do this one, we're actually going to keep the E in the alkane name. So if you just have one alcohol group, if we go back up to my rules up here somewhere, way up at the top, we said to replace the E in the alkane name with OL. This time we're going to keep the E. So we're just going to add diol or triol to the end of it. So the E in the alkane name stays. Whoa, that is not a pen, that is my highlighter. The E in the alkane name stays. Sorry about that. I don't make up these rules, so you can't really get mad at me, right? I'm just the messenger. So an example, if you have more than one OH group, you want to number it so you have the lowest sum for those OH groups. Not for the OH groups. Again, you're not numbering the OH groups, you're numbering the carbons. I always say OH group, but you want the lowest sum for the carbons that are bonded to those hydroxyl groups. So this is going to be carbon 1, 2, and 3. So I have 3 carbons. If we want to do the older method, 1, 3, right? If I have 2 things, I need to say where they are. So if I had 2 methyl groups, right, we would do dimethyl, and I would have to put the 2 numbers, and I would have to put a comma between them. That sort of nomenclature still stays. So if you have 2 groups, I need to say where they both are. Since I'm going to put 2 numbers together, I need to put a comma between them. So 1, 3, and then 3 carbons is prop. They're all singly bonded, so ane, but I'm going to keep the E this time, and then diol, because there's 2 of them. So 1, 3 propane diol. The newer method, propane, and then the 1, 3. So in the newer method, remember, our numbers come right before the ending. In the older method, the number comes before the parent. Do watch out for this. There's actually an old method, and it's not very common anymore, but if you're looking up other naming systems or you're looking at problems on the internet, and I actually learned it this way, so every once in a while I'll say it. I'm pretty much out of the habit now, but again, every once in a while I'll do it. We'll do prop, diol. So be careful. I don't want you to do it this way. It's really old, it's antiquated. Just watch out for it. So this is an old method versus the old method and the new method. So we kind of want to stay away from doing that, but you might see it. If you do, that's what's happening. There are some common names that are still somewhat common. I don't want you to name it like this on tests or quizzes. We are going to name them using IUPAC, but these are out there. You will see them. So I do want you to be aware of it. So our common names, they were named as alkyl alcohols. So the carbon part would be named as an alkyl group. So instead of ethanol, it would be ethyl, right? 2 carbons as an alkyl group is ethyl. And then the word alcohol would be put at the end of it. So ethanol would be our IUPAC name. Ethyl alcohol would be its common name. One that is kind of commonly used is this one. So if I was to just look at, sorry, I'm trying to get my highlighter here. If I was just to look at this part, right, and name that as a substituent because it's bonded to the middle carbon, it would be an isopropyl group. So this would be isopropyl alcohol. So rubbing alcohol is usually somewhere around a 70% solution of this, and it'll say isopropyl alcohol or isopropanol on the bottle. Isopropanol is also not IUPAC. It's closer to IUPAC, but it's not. If we were to name this using IUPAC, right, I would do 2-propanol or prop and 2-ol, right? Older method and the newer method. Isopropanol is accepted. It's a lot closer to IUPAC, but the way we're going to name it are using these rules.